Okay, so I'm supposed to find the sum, or they're asking me how many terms are in the series, okay? And I know, so the series, the sequence that I'm getting the series from here, let me write this in red. 5 and 25, and then 125 plus, I don't know, all the way up to the fifth term, or the last term is equal to that number there. So I know this is geometric for a couple of reasons. If I take 25 divided by the first term, so the second term divided by the first term, I get 5. And 125 divided by 25 is also 5. And then they also tell me that the sequence, that the nth term for the sequence is 5 to the n. So I know it's a geometric series. And because this isn't an infinite geometric series, I know it's going to be a partial sum. And that's the formula for a partial sum, where the first term is a sub 1. Common ratio is what you do when we do the division, and then how many terms. So what do I've got going on here? Let me scroll down here and we'll take a look. I think it's on the next page. So I decided that R was the 5 and the first term was also 5. So I substituted those into the formula. First term times 1 minus the common ratio to the nth power. If I knew what n was, I could actually calculate that value, but we have to work backwards, of course. So 1 minus 5 is negative 4. I'm going to multiply both sides of this equation by negative 4 to get rid of the denominator, and then that gives me this. And then I could distribute the 5 through, but why can't I just divide by 5? And that will make it, I think it makes it a lot easier. And then I'm gonna rearrange this. I brought the 5 in over here by adding it. I added that to the over here, and then I gotta solve this exponential equation, and we could certainly do that by taking the log of both sides. What I try to emphasize to my students is that if you have an exponential equation and it isn't making sense, rewrite it as a logarithmic equation. So the base is 5, so log base 5 of the answer equals the exponent. That's what we're looking for. And then that's just the change of base formula. Remember the change of base formula is if log base a of b, you can change that to base 10 by saying log of b divided by the log of a. So that's what I did here. You could also do this with ln. I tend to use log. And I got 8 point blah 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 on my calculator, but obviously that's just a calculator error. And so there's 8 terms. Hopefully that helps you do your version of this question.